Welcome back to the Foundry by Forge College. Now, if you survived our previous explainer on privacy enhancements and their user-centric effects, you've honestly already done the heavy lifting for this module. You've gathered the raw data, you've mapped your metrics, and today we're capping off this advancements in Bitcoin track. We are going to take all that raw Bitcoin data and assemble it into a beautifully documented Capstone engine. Because let's face it, your brilliant research doesn't really mean much if it reads like a messy grocery list, right? So this explainer is all about synthesizing your hard work into a razor-sharp, highly structured draft. Let's get to it. Here is the blueprint for our assembly line today. First up, the blueprint itself. Then, 2, embedding artifacts. 3, mechanistic linkage. And finally, number 4, the peer review protocol. All right, part 1, the blueprint, structuring your masterpiece. I want you to think of these sections like the strict requirements for a patent application. Every piece has a designated slot. You need an abstract, and keep it tight, like 60 to 100 words tops. Your introduction needs to clearly state your thesis. The methods section is where you list your data sources. Then, results hold your hard metrics. The discussion handles your privacy analysis. And finally, wrap it all up with a solid conclusion. Look, if you try to reinvent the wheel here and submit a document without this exact skeleton, well, your engines simply won't start, and you're just going to give your reviewers a massive headache. Moving right along to part 2, embedding artifacts, the parts list. So now we need to actually install the parts. You must embed 3 very specific transaction demos exactly as you built them. We're talking about your tx-segwit-sample, your tx-taproot script path, and your tx-combined demo. But listen, you can't just drop the file names and move on. No way. You've got to include their raw hex or JSON formats, the exact construction command you used to build them, and the measured metrics, like your vsize and linkability. Think of these as the pistons actually firing inside your Capstone draft. So what do we actually mean by artifact embedding? Basically, it means creating a formatted section that contains absolutely everything a third party needs for total reproducibility. Fill name, purpose, raw data, tool reference, and metrics. The whole shebang. An inspector should be able to look at this and reproduce your exact measurements without guessing a single parameter. Zero assumptions allowed here. Which brings us to part 3, the mechanics, connecting claims to evidence. Once those parts are installed, how do we prove this thing actually works? We use a little assembly sequence we call mechanistic linkage. It's a 4-step process for every single assertion you make. Step 1, you make a declarative claim. Step 2, you immediately back it up with the supporting artifact reference. Step 3, drop in the hard numbers and measured data. And step 4, give us the technical mechanistic explanation of why those numbers actually happened. You're stepping directly from theory to undeniable, reproducible proof. Let's look at how you actually map a claim directly to evidence. Say you're claiming that Taproot improves privacy. Well, you map that directly to your Taproot script path artifact, showing its exact vsize of 225 and a linkability score of 0.32. Claiming SegWit reduces weight points straight to your SegWit sample, weighing in at exactly 1,025. See what we're doing here? It leaves absolutely zero room for vague, unanchored opinions. Now, when you're writing out your discussion, you absolutely have to clearly separate the mathematical on-chain changes, like output indistinguishability, from off-chain human behaviors. You know, things like someone just sloppily reusing an address. You have to know exactly where the protocol's privacy ends and human error begins. Oh, and speaking of human error, please spell check your text. Even the most brilliant engineering schematic looks completely amateur if you misspell Bitcoin. All right, part 4, the quality inspectors, the peer review protocol. Let's be real, a bad peer review is just vague. Getting a comment that says, "Looks good, bro," is literally useless for an engineer. Effective feedback, the exact kind we demand here at Forge College and what you'll see in real-world Web3 communities, is highly structured. It tells you exactly what's broken, how critical it is, and the specific version that needs fixing. You're going to assign 2 peers to review your draft, and you must hold them to a super strict turnaround time of 48 to 60 hours. We have to keep this assembly line moving, right? Open-ended deadlines just lead to stalled projects, and we do not have time for that. To make sure your peers can actually get the job done in that 48 to 60-hour window, they'll run through a precise diagnostic checklist. They're going to verify that the document structure is all there, all 3 artifacts are properly embedded, the metrics are actually reported, and that mechanistic linkage we talked about is mathematically sound. A good reviewer should easily run through this entire diagnostic in about 15 to maybe 80 minutes. And when they hand that report back to you, it needs to use feedback item labeling. That means tagging review comments with a specific severity level, either a major or minor. It has to include a perfectly actionable change, and it needs to target a specific draft version. So, if a major item fails, like say you completely forgot the linkability score for the combined demo, that gets flagged as a major error for an immediate fix sprint before you even think about hitting submit. And that brings us to part 5, sign off, finalizing your draft. Okay, so you've got your structured feedback. What's next? You clear out the highest priority major revisions from your peers on version 1.0. Then you simply increment your draft to version 1.2, and you prep your export-ready Capstone final assets folder. This keeps everything beautifully organized and gives your instructor a completely clean, sanity-checked package to review. Before you submit the whole shebang, look at your draft and honestly ask yourself this. Are all your claims tightly anchored to your metrics? Is this drafted schematic actually ready for its final polish? Every single assertion you make must be anchored to hard data. If you can confidently say yes to that, you are setting yourself up perfectly for the final presentation. Well, there you have it. You've built the engine, tested the linkage, and passed inspection. Head over to forge.college to dive deeper into these Bitcoin fundamentals and check out our other Web3 communities. But before you go, I want you to think about this. As privacy protocols on Bitcoin continue to get more and more advanced, will the ultimate vulnerability be the code itself or the humans actually using it? I'll let you chew on that. See you in the next explainer.